In today's lesson, we are going to look at, or we are going to discuss the character of an inductor in an AC circuit. So, when an inductor is connected in an AC circuit, let's see what happens in AC circuits. Let's see what happens at this point, and then we'll move on with that. Okay? Let's see. If an inductor is connected in an AC circuit, what happens? Or how does it behave? Okay, so first of all, we do a diagram that represents the connection of the inductor in an AC circuit. Okay, so we have this. This remains an ammeter that measures the current. Okay, then we extend it once again. Our diagram is taking shape. The key, right? Then the alternating voltage source. This is our key, right? The alternating voltage source. Let me pick chalk. Is this, and we complete it this point. And this point is completed. Okay? We still have to measure the potential drop across the inductor, and it's going to be VL. Okay? That is inductive voltage, VL. And we have this all through. An inductor is represented by a letter, a small letter. All right? That's L. Okay? L. Now we have this. These are arrangements that has to do with the connection of an inductor in an AC circuit. We are going to check 2 or 3 things. One, the current flowing here, the behavior of the inductor with the alternating voltage or AC voltage. Okay? Good. As usual, we have that V is equal to V naught sine omega t. And then if this is true, it means we have I naught sine omega t. Good. So we have this. Any of these will be used to identify 1 or 2 parameters here. So when an inductor is connected, it offers some amount of resistance. It reacts, okay? It opposes somehow the current flowing through it by developing some kind of a opposing electromagnetic field, excuse me. Okay? So it produces some kind of magnetic field that will now oppose the current. That is another action, right? So what we need to know is that the inductor is measured in Henry H. Okay? Now, what do? We equally have to apply Ohm's law. So if we apply Ohm's law, first of all, we state our Ohm's law to be V equal to I R. But in place of I, R, we now look at reactance, the inductive reactance, XL. The inductive reactance, XL, takes place because there is some amount of opposition that this inductor offers to the flow of current. All right? If we understand that, that means we are going to walk through that and to find the inductive reactance of the inductor, XL, is equal to 2 pi ft. Good. So with this, we can, not ft, fl. Okay? 2 pi fl. Okay, with this, we can now find the reactive or the inductive reactance of the inductor. We move on again. Since we have found this, we can now state current flowing in this could be V naught sine omega t all over the inductive reactance. So with this, we can find the current flowing through this. That's what it means. Okay? If we understand this, that means everything is very simple. We move on to define that I, current flowing in this, okay, remains the same with this. We're talking about the root mean square here. We have something like that. Then we have V RMX all over XL. It doesn't change. All the same, if we understand this concept, we can solve as many problems coming from this. So with this, we are good. We cannot solve anything from this section. The next thing we need to do, the behavior, we have found the current here, right? We need to know the behavior of the inductor offering some amount of inductance when it is connected in AC circuits. Okay? The behavior of the inductor with the what? Alternating voltage source. How does it behave? So what happens is that if we have this, watch this, if we have something like this, I'm going to draw a very simple diagram to illustrate something. We have something like this. This is VL, the inductive voltage. The inductive voltage will lead. Somehow, it will lead. Okay? This is current. Or so to speak, with time. This is just time. Okay? Now, if we have another one, if we extend this diagram to accommodate the character of current when it flows into an inductor in an AC circuit, it means that current starts from zero, moves up. This is current somewhere here. We have current L, moves up, comes down, moves up again, and so on and so forth. This is time. Okay? So watch the two diagrams. Look at these two illustrations. When the current is at zero, already the voltage is maintaining some amount of value at this point. That means it leads. Okay? It's leading at this point. Current is about to come up from zero. So it's leading. In summary, the inductive voltage, VL, leads the capacitive, the inductive current, IL, by a factor pi over 2. That's what it means. I repeat, the inductive voltage leads the inductive current by a factor pi over 2. So we can now redefine the inductive voltage as VL is equal to V naught sine bracket open omega t, okay, plus pi all over 2. So that's the factor. That's the factor by which it leads. So we take note of that. Even if we are trying to find this, we substitute accordingly. So we can now redefine the current as IL is equal to VL, which is this over this. So with this, it goes. So we're making progress. Look at it. That's what happens when an inductor is connected in an AC circuit. Watch it. First of all, we define the inductive reactance as this. This is the inductive reactance. So with this, we can find the value of opposition being offered in the circuit when an inductor is connected. And then we move on from there, we find the current, the root mean current, the steady current that causes heat in that element or in that coil, because an inductor is a coil, right? And then we move on to finding the relationship between the inductive voltage and the inductive current. We now found that the inductive voltage leads by a factor pi over 2. Interesting. And then we redefine all that for us. So we have done this to the point that wherever the question comes, we will understand what happens. So we know that inductive voltage leads inductive current. Okay? Please, if you have not watched my video in what happens when a resistor is connected in a AC circuit and what happens when a capacitor is connected in an AC circuit. Please go and watch the 2 videos. I will link them somewhere there. Okay? Thank you so much. Off I go. Remember to subscribe, thumbs up, and then push on the bell button for constant notification. Share with your friends, networks, and students. See you there.